This video we will continue to discuss compound inequalities, but this time we have two separate inequalities joined together with word or. So this is going to be the key word here. All right. So let's just go ahead and start with the mechanics. Okay, so we have two separate inequalities. 6 is greater than 2a minus 1, and negative 4 is less than or equal to negative 3a plus 2. So we're just going to solve this separately. I'm going to draw a line in between. Okay. All right. So first, we will add 1 to both sides, plus 1, plus 1. So we have 7 is greater than 2a, divide by 2, and we simply have 7 over 2 is greater than a. So we'll just leave it at that for now, and let's just move on to the second one. Here we will subtract 2. So we have negative 6 is less than or equal to negative 3a. We will divide by negative 3. Be careful when you divide by a negative, the inequality symbol reverses. So we have 2, because negative 6 over negative 3 is greater than or equal to a. All right, so we got these two separate solutions like this. Remember, this 2 are joined together with word or. Okay, what does that mean, or? Let me just go ahead and so-called graph each of these two. I have 0 sitting here, and 1, 2, and 7 over 2 is 3.5. So 3 is here, 4 is here, and so here is 7 over 2. Okay, 7 over 2. All right, so we got this point here and this point here. It's our so-called two endpoints. First, this means a is less than 7 over 2. All right, so less than. So that means everything less than 7 over 2. Okay, and I have to kind of be careful here. And I'll put a dot there, but that should have been a hollow point. Hollow because 7 over 2 is not included. Everything less than that, that's here. Okay, and the other one, a is less than or equal to 2. So the other one starts at 2, including 2, and goes down. All right, so those two are the graphs of the two solution set that we got. All right, these two. Okay, and our final solution is supposed to be put together with word or. Or means if a number is in either of the two sets, it's a solution. Okay, so let's inspect. There are actually 3 regions. What are the 3 regions? One is here. That's everything less than 2, and you can see it's covered by two red lines. And then we have one in the middle, and then we have this third region. Let me just label as region 1, Roman numeral, region 2, region 3. Okay, I know green sometimes doesn't show too well. Hope you can see that, region 1, 2, and 3. Okay, and let's just look at which sets satisfy this statement. Okay, region 1 clearly satisfies because it's in both. I know sometimes in English when we hear the word or, it can only be one. No, mathematically it can be both. Region 2 clearly is satisfied because it satisfies just one of the two. Region 3 clearly is not, because no number is in either of the two. So this is clearly, I'm trying to look for, not a solution. But 1 and 2 are. So our final solution is going to be, I'm going to write the answer in 2 different notation. I'm going to start with the interval notation. Our left endpoint is negative infinity, because that line goes on forever to left. And it stops at 7 over 2. Does not include that, so it has to be written as a parentheses. Okay, or in set notation, sometimes we write it this way: set of all x such that x is less than 7 over 2. All right, that's the answer for this particular problem. So actually that 2 here doesn't really come into play in writing our answer. All right. Okay, let's look at number 2 problem. All right, we're going to approach this similar way where we solve each one separately. And so let's begin. So plus 7 on both sides. So 3x is greater than negative 3 divided by 3, and we have x is greater than negative 1. All right. And the second one, subtract 2. 5x is less than or equal to 20 divided by 5. We have x is less than or equal to 4. Right. Okay, let's see how this looks when we if you can see how the graph looks like, that's good. If not, then I would try to draw a picture. Let me go. I'm going to go below. Let's see. This line is too long. Okay. So let me draw number line. 0. There's negative 1, 1, 2, 3, 4. Those two are our endpoints. Okay. The first solution, x is greater than negative 1. So it's everything starting at negative 1, but not including negative 1 greater. Okay, and the second one, x is less than or equal to 4. So including negative 4, it goes to the left. Okay, now you look at this and think which solution set satisfies the statement or. All right, the statement or here. Okay. So are there any part of the number line that is not covered by either of the two? If you look at carefully, everything in the number line is covered by this two solution sets. Okay, including the one in the middle. It's in both. Remember, in mathematically, if you are in both sets, you still satisfy the word or. So there are several different ways you can write the answer. In terms of interval notation, I'm going to write it as starting from negative infinity to ending at positive infinity. That kind of looks like, make sure it's parentheses. All right. Infinities never get a bracket. Okay. Infinities always receive parentheses. Or you can say set of all x such that x is an element of all real numbers. Or if you just write, I think I wrote this in previous video, that means this double capital R means set of all real numbers. All right. Okay, and the last problem, we'll start out the similar way. Okay, so we have 2c adding 1 on both sides. 2c is greater than 6, divide by 2, c is greater than 3. And this one, second one, subtract 2, negative 3c is greater than 9, divide by negative, remember we're dividing by negative, so that has to be reversed, so c is less than negative 3. Okay, we got these two endpoints. So c is greater than 3, c is less than negative 3. If you draw a number line on this, here's a 0, here's negative 3, here's 3. First one, everything greater than 3, everything less than 3. Okay? There is no overlapping region like we had in previous two problems. Doesn't matter. So I'm asking which part satisfies either of the two. Well, we have what we call two distinct sets. So left one is negative infinity to negative 3. Right side, we have starting at 3, ending at positive infinity. And those two sets really make up our solution set. And you cannot just leave it like this. You gotta say something. And the notation, it's a set notation. We use U. This stands for union of two sets. Okay, you can use that, or sometimes you can use a word or, the same or that we've been using. All right, or if you are curious how to write this set notation, it would basically, it's C, not X. Okay, C. So C such that C is greater than 3 or C less than negative 3. Okay, so